Ixie, welcome back to the channel. So we're basically continuing from where we left off. We did number 1 where we're looking at determining the equation of each of the circles. Now we're going number 2, 3, we'll do 4 and 5 just like that. So let's just do them in order and then we keep it moving. With number 2, we're required to sketch graphs for the following circles and show at least one point other than the x or y intercept on the circle. So let's quickly look at that. So you look at the fact that we are given the equations as they are, and we're required to just create some rough sketches. So we don't have to be too fancy with the sketch, just need to show exactly what we are required to show. Let's look at A. We're given x squared plus y squared equals to 25, just like that. So you can see this is in standard form, which therefore means r squared equals to 25, and r equals to the square root of 25, which therefore means r equals to 5. So if r is 5, how do we sketch this thing? Okay, before we do the sketch, or let's rather just get the sketch and then we will see. I think that will be the easier way. Okay, sketch will be something of this nature, and then we might try to include the Cartesian plane like that. Yeah, something of that nature. From there I come with my handwriting and extend these lines. It will look like this. This is 5, this is negative 5, this is 5 again, this is negative 5. That's our Cartesian plane, our x and y. So as you can see, we are required to show another point which is on the circle, and it also has like what is it? We're just required to show another point which is not the x or the y intercept. Sorry. So you can think of point like this. So we can just guess any y value that we know that it's there and get some corresponding x values for that y value. Or we can just maybe guess an x value here and then get its corresponding y values like that. Okay, so the way I would go about it is to guess on this equation y squared plus x squared plus y squared equals 25. I can think of a valid value of x, probably maybe 1 or a 4. I'm thinking of 1. I'm gonna put 1 there, plus y squared equals to 25, just to get the corresponding y values for 1. If x is 1, what will be its corresponding y value, so that we can know these 2 points like that. So that's exactly why I'm doing this. Oh no, let me get back to using the blue color. Y squared equals to 24 like that, because 1 squared is just 1. So y is actually equals to plus minus the square root of 24. If that can be simplified, we'll find out from the calculator. Square root of 24, it actually can, plus minus 2 root of 6, that is that. And now we can show this point as, what is it, negative, okay, let's put it as coordinates 1 and negative 2 root of 6, and then that point there is going to be 1 and positive 2 root 6 like that. So we are done with all the other examples. Like this one, we just do the same, and then we'll have a sketch similar to that one, but the radius will definitely be different, because the radius is given from here. We say r squared equals to 8, therefore the radius equals the square root of 8, just like that. So I'm not gonna do the same thing repeatedly. You can see how to do it from A. You'll just let me know with the answers. And then for C, what's happening with C, they just introduced Abu 2 there in front of the x squared and the y squared. So you know you need to divide throughout by that 2, so that you can eliminate these 2's. Okay, so you'll have x squared plus y squared equals to 32 over 2, which is basically 16. That means y squared plus x squared plus y squared equals to 16. And then you have your equation in standard form. Then you come back to doing exactly the products that we did there. As for which one, this one, just move this 9 to this side. So you'll have x squared plus y squared equals to 9. This is the standard form. Then you know how to continue going forward to create a sketch and find some points which are which are on this circle. We move on to other things. This other one of E is just the same standard form, so you'll be fine, I trust you. Okay, and number 3, what's happening? We're going to determine the equation of a circle with center at the origin, and we are given the radius. So if you are given the radius and the center is at the origin, this is your standard form. So when you're given the radius, just need to plug in the radius there. So you have 16. That means your equation is x squared plus y squared equals to 16. We're done. No need to be worried. Same applies. You're given the square root there, which is the radius. So you're just going to plug that thing there. So instead of me putting 4, I'll plug the square root of 10. And when I square that, I'm left with 10. Then the answer will be that for B. You see that? I hope you see what's happening. Let me just try to be neat. Something of this nature. That's for B. And then for C and D, they give you they give you points rather, which are on the circle. So you still use the same format. And then if they give you a point, just need to substitute that point. For instance, you can substitute this one of root 3, square that, and then its y value is 1. Then it gives you what your r squared equals to. This is 3 plus 1, which is 4. That's equals to your r squared. Therefore, the equation is given by this. equals to r squared, which is 4. Then you are done with the equation. So let's move on to other things which are a bit maybe interesting. Number 4, what's happening? They still give you a point which lies on the second, and the equation of the second is given for both a and b, as you can see. So you can just choose, let's do b. With b equals 21, like that. We have a point which lies on the second. If this point really lies on the second, that means when we substitute this point here on the equation, the left hand side will remain being equal to the right hand side. So let's substitute. A is the x value, and then square root of 5 is the y value. So we're just gonna do that. That means our 5 equals to, like that, a plus 5 equals to that. Therefore, a equals to, what is it, 16. So, okay. No, this is a squared, not a. I don't know why I just left the square. But yeah. So, a equals to plus minus the square root of 16, which therefore means a equals to, what? Is equals to plus minus 4. So, yeah, a equals to 4 or a equals to negative 4. Done. With circles, always get used to putting plus or minus, because you can never know for each like for if we use this circle as an example, for each value of y you have two values of x that correspond to that, and for each value of x you usually have two values of y corresponding to that. That's why we always use the plus or minus. Number five, what's going on here? We are given a point, it lies on a circle, and that circle has the center, the origin. So we are back to the standard equation, like that. And then what are we given, or what are we being asked to do? We're being asked to determine the equation of the circle. So yeah, already we know that we're dealing with the standard equation. So they give us a point to determine the equation of this circle. We're just going to substitute this point on this standard equation. Minus 5 squared plus 12 squared equals to r squared. What is this? This is 169. That is equals to r squared. Therefore, now we just write this in the standard form. And we are done with the equation of the circle. B, we are required to determine the coordinates of Q if we know that PQ is a diameter of the circle. So let's look at this, something of this nature. And then we already had some things being given to us. We had Q rather being given to us. So I'm just gonna try to extend these lines like that. With my bad handwriting, it's fine, don't have to kill me. P and Q, we're told that PQ is a diameter, therefore it means it passes through the center, like that. And as a result, this is your radius, this is your radius. By radius I just mean this, so what the radius is, so you get it. Okay, so if this happens to be the coordinates of P, which is -5 and +12, therefore it will mean this is also 5 units, which means here is 5, and then here is also 12 units, this is -12. Therefore, what are the coordinates of Q? It's basically +5 and -12. Then we are done. You know the coordinates of Q. And C, what is happening? Show that this point, it lies on the circle. If it lies on the circle, and we have the equation of the circle, you see that equation of the circle, I hope you still remember that, is the equation of this very same circle. So if that is the case, this point m of 0 and -13 lies on the circle, the left hand side will remain equal to the right hand side, which is 169. So we're just going to substitute x squared plus y squared is supposed to give us 169 when we substitute. This is the x value. So the 0 squared plus -13 squared, is that 169? It is 169. Therefore m lies on the circle. Okay, and then the last question, which is D, we are required to show that this angle is actually 90 degrees. How do we show that angle is 90 degrees? Let's go back to the sketch. Oh wow, these are not supposed to be here. Okay, let's go back to the sketch. In the sketch, you'll see that, wait a moment, what's going on? Okay, so we'll have something of this nature. No, this question doesn't want to be done. Okay, it does want to be done at some point. This is our m, -13. That's where m is. So we are required to show that this angle, which is PMQ, is actually 90 degrees, like that. We can do this thing, I think, in two ways at this point. Remember, if that angle is actually really 90 degrees, that will therefore mean the gradient of MQ times the gradient of MP, it's actually -1. And we have these coordinates of MP and Q, so we can get their gradients. So let's get the gradient of MQ rather first. Remember, this is 0 and -13. What would that be? That would be -12 minus -13, or divide by 5 minus 0. That should give you I think 1/5, and then get the gradient of PQ, or PM, not PQ, PM, yeah. So what is that? That will basically be -13 minus, what is it, the y value is 12 there, and then divide by 0 minus -5. Okay, what do you get? I think it's -5. And then now you just need to say the gradients when you multiply them together. That is mq times mp equals to 1 over 5 times -5. That gives -1. Therefore that angle, what do they call it, PMQ equals to 90 degrees. Hey, let's leave this thing here. We are done.